So until we have a better definition, I can't give you a precise number for effective temperatures, but what I can do is show you how different chemicals compare to each other in their relative ice melting power at different temperatures. So calcium chloride and magnesium chloride are really our main workhorse chemicals for getting ice melting at colder temperatures than salt. So this graph shows you an illustration of the relative ice melting capacity of salt and calcium chloride at different temperatures. I did not include magnesium chloride in this graph. Magnesium chloride will be similar to calcium chloride, but somewhat less effective. So the blue bars show you pounds of ice melted per pound of chemical for salt, the red bars for calcium chloride. Note that at 25 degrees Fahrenheit, we actually get more ice melting from salt than we do from calcium chloride. There is no advantage to the more expensive calcium chloride or mag chloride at warmer temperatures. You're going to get more melt per pound and a lot more melt per dollar with salt at warmer temperatures. Now let's drop 10 degrees. We'll go down to 15 degrees Fahrenheit. Now we see salt and calcium chloride are about neck and neck. 5 degrees Fahrenheit, now we start seeing a real difference. 5 degrees Fahrenheit, calcium chloride is melting about twice what salt is. And then when we get down to 0 or colder than 0, we're not getting really any melt from salt at all. But calcium chloride keeps melting all the way down to minus 25 and will melt even below that. Whoops. Oops. I'm going. OK. So calcium chloride and mag chloride will give me melting at colder temperatures. They're also, of course, more expensive. Calcium and mag chloride are more expensive than salt brine. So commonly, we do not use them as direct application chemicals. And sometimes we do, but often people will try and blend them with salt brine in order to manage costs. And that gets us into the world of the hot mixes. So what are hot mixes? Hot mixes are where we take a relatively low-cost brine, like a salt brine, and add some of these performance-enhancing chemicals, like a liquid mag chloride or calcium chloride or agricultural or organic byproduct, to try and squeeze some additional effectiveness out of that salt brine at a more manageable cost than applying these expensive things directly. So let me spend a little bit of time talking about what we can understand about the effect of these different sorts of blends and what they do. So for openers, let's take a look at some organic agricultural byproduct type additives. This graph shows you the freezing points and the ice melting capacities of a magnesium chloride brine blended with varying amounts of an agricultural byproduct. So first, let's take a look at the blue line. Note that the freezing point of my brine drops dramatically when I add more of the agricultural byproduct. Now, we might be tempted to stop at this point and say, fantastic, I've lowered the freezing point of my brine. It's going to work much better now. I'm going to get much better ice melting at colder temperatures. But from the earlier part of our talk, now you know that we need to be a little bit careful about jumping to that conclusion. Let's actually take a look at what the ice melting capacities look like. The red line shows my ice melting, and note that as I increase the amount of agricultural byproduct in my mag chloride liquid, I steadily lose ice melting capacity. So what the heck is going on here? I'm dropping my freezing point, but I'm not gaining any ice melting power. How do we understand this?